Okay, now this session we'll learn about Ohm's law. If the voltage in your homes increases, what do you notice about your electric bulbs? You suddenly find them glowing more brightly. And if the voltage decreases, we find our electric bulbs become dim. And this is an experience in everyday life. Higher the voltage, more is the electric current. And that's the reason why sometimes we do not want very high voltage, because if the voltage gets very high, the current also becomes very high, and this could damage our appliances. So there is a clear relationship between voltage and current. More is the voltage, more is the current. This relationship was studied by Ohm in his law called the Ohm's Law. So here is the circuit diagram, and in this circuit diagram we have the cell here. This is the cell. Many cells together make a battery. Now this cell, have you seen, it is all like this, connected to an ammeter. This ammeter will help us to measure the current. Ammeter helps us to measure current. Now we go along the circuit again, and here we have a resistance. This is a resistance, could be a appliance, it could be a fan, it could be electric bulb. And across this resistance here, there is a voltmeter here. Here the voltmeter is. This voltmeter measures a potential difference. And then we follow the circuit again. Here we have the switch in order to put it on and off, and back again we get to the cell. So this is a complete circuit with the ammeter here. This is the ammeter to measure current. This ammeter to measure current, and we have the voltmeter here to measure the voltage. So here ammeter to measure current and the voltmeter to measure the voltage. So what Ohm did was, he kept changing the voltage in the circuit and he measured the current. So let's make a table. So here is a table of voltage and current. So first he applied a voltage of 5 volts. So there was a voltage of 5 volts, and then he recorded the current, and he found that the current was 10 amperes. Then again he increased the voltage. He increased the voltage, say, to 7 volts. Now definitely there will be an increase in current. But now the current was found to be 14 amperes. Then he further increased the voltage to 10 volts, and by now you would have guessed the current became 20 amperes. More voltage, more current. And again further, say, he increased to 25 volts, and now the current became 50 amperes. So you have noticed is more the voltage, increase in the voltage, increase in the current. But there is something that remains constant here. See, it is V over I. Let's do V over I in the first case. V is 5 and your I is 10. And you see V over I becomes not 2, 1 by 2. In the second case, you have 7 over 14, and that becomes again 1 by 2. Then 10 over 20, 1 by 2, 25 over 50. So V over I remains a constant called resistance. The constant has got a special name called resistance. Here is Ohm's law. The current flowing through a conductor is directly proportional to the potential difference. What do you mean by directly proportional? More is the potential difference, more is the current. So we just write it out. So we have here V, potential difference, directly proportional to current. So, and you know in mathematics, when the proportional sign now it changed to equal, we have to introduce a constant. Okay, so now we have So back again. So V equal to, now this constant here is R, the resistance, and it is called the resistance. So this R is the resistance. So here's the formula, V equal to IR. It's a very important formula which we use a lot in electricity. Now let us discuss what is this resistance. What do you mean by resistance of the wire? Now we already have seen in a wire, we have the wire and the flow of current. What is a flow of current? Are just electrons moving about. All electrons moving in one direction. But however, these electrons are not free to move because there are nucleus inside. You know, inside the atom we have the nucleus, and this nuclei attract the electrons. So every wire, it offers a resistance. The electrons are not free to move. There is a kind of resistance that the electrons experience. This resistance is called, this resistance is a resistance of the wire. More is a resistance, less is a current flowing to that wire. And this resistance, we know, like I said, is a force of attraction of the nucleus. The nucleus pulls the electrons towards itself, and hence they are unable to move to the wire. So that is a resistance. Ohm's law says V equal to IR. So if V equal to IR, your R equal to V over, your I will be equal to V over R. That means I is equal to voltage, not current. Voltage over resistance. So here the current I depends on two factors. The current I will depend on two factors. One is the voltage. This one voltage here, not voltage, and the other factor on which it depends is the resistance. So more is a voltage, more is a current, but for resistance, more is the resistance, less is current. Because we know I equal to V over R. More is the R, greater is the denominator, less will be the fraction. So this is inversely, means, again I repeat, less resistance, more current. However, for voltage it is different. More voltage, more current. Bigger will be the fraction. We'll also now take up resistance, give it a unit and define that unit. Resistance is written like this, ohm. The unit is ohm. Okay, ohm. Now let's define 1 ohm. So we know that V equal to IR. That means your R equal to V over I. Now if the voltage is taken as 1 volt and the current is 1 ampere, what will happen to the resistance? It will be 1 ohm. So what is 1 ohm? 1 ohm is if you have a wire here, here's a wire, and to this wire you apply a potential difference, say of 1 volt. You apply a potential difference of 1 volt. So here is a circuit. We have a resistance here. This is a resistance here we have. Okay, say this is R. And to this resistance, I want a current. If I want a current, I have to apply a voltage. So I apply a voltage of 1 volt. And when I apply a voltage of 1 volt, I find the current passing through this wire is 1 ampere. Then voltage is 1, current is 1. I can say my resistance is 1 ohm. So what is 1 ohm? I repeat again. If voltage applied, here the voltage applied is 1 volt, after applying a voltage of 1 volt, if the current flowing to the circuit is exactly 1 ampere, our resistance is said to be 1 ohm. In the notes you will have the definition there. So here in this diagram, the voltmeter is measuring 1 volt. The ampere is measuring a current of 1 ampere. Hence the resistance will be 1 ohm.